as I just said, we're going to get into our controllers. We've had a look around. We've done a few things inside of our controllers so far, but we now need to actually get into it much more deeply. So I'm going to start with the patient controller, right? Gives us a chance to work through the whole thing and look at some improvements we could make along with everything else. So, as we discussed, we already have the constructor up here. With dependency injection, we get our DB context. So let's start next with a quick review. We have the index, details. Again, I'll go control MO, shrink everything down. Index and details, and then paired, create. We have a get and post, paired edit, get and post, and then delete. Now, because you'll notice here, the signature, the parameters being passed to the second delete is the same as the first one, unlike all the others. That's why the name has been changed here to be delete confirmed, right? The annotation, the fact that this is telling it, no, if it's a post request that comes in and the name is delete, that would bring it here. But we can't, due to the rules of C#, we can't have two actions here with the exact same name with the exact same signature or parameters, right? So that's why this name is a little different, and therefore we specify here action name delete. So if a post comes in and the action is delete, it comes here. I could call this anything I want now. I could call it Fred eats fish on Fridays, and it would still work fine, right? Okay, anyway. Then we added our populate drop-down list. Remember, we consolidated this into one quick little void method here that we can call whenever we need to prepare data to show in a drop-down list of doctors. And then this at the end was just, it's a standard thing scaffolded in all our controllers, just a quick check if something exists. We're in the patient controller, so it's whether the patient exists. All right. So let's go back up to the top now. So the index, we understand the concept. The index is basically the list of all the data, right? One of the things you'll notice right away, why is this name here? Medical office contacts. Well, the truth is, at the point where it's scaffolding the system, the scaffolder doesn't have much information about it to work with yet. So it uses about the only thing. It knows that we're doing this, working with the medical office contact, so it just grabs that name. There's no reason for it to have this name. It really should obviously be patients, right? The name of our collection. So just make sure that we update that in both spots here, right? So this is an example of what we're really doing. This is a LINQ query, right? Notice that this is a includable queryable of patient because we're including doctor, right? That's what the type of objects that we have here. And then it actually executes the query when we say toList async. That's when it will go and execute this LINQ query, right? So we have the context using extension method syntax dot patients, okay, gives us our DB set of patients. And then with this dot include, what we're saying is, hey, remember way back inside of our patient model, we had this doctor object down here, right? So we want to actually include the doctor as an object as we construct each patient. Okay, all right, so that's what that is doing for us. Now, one thing I might mention, we talked earlier about the fact that this dot include is a super standard query operator that helps us avoid almost exclusively writing joins in our queries here, right? If I wanted to, I could have done this whole thing with this approach instead. Okay, there we go. I'm using, in this case, our query expression syntax from P in, okay, context.patients, join D, okay, as a placeholder variable for context.doctors, on, well, there's my primary foreign key relationship, okay, using this syntax here, equals, and so on, right? And then I can select new patient objects, populating all the properties from the data coming in, right? This would work as well and would get the job done. But let me ask you, do you want to have to write this kind of code every time you go to do a query, including something and having a relationship? Or would you rather stick with this? I think it's obvious that this is the way to go. Okay. All right. Just be aware that at this point, though, as I said, this is a includable queryable. In our PowerPoint, we talked about the fact that what we would probably like to do is have our queries return a simple iQueryable of the actual object we're focused on, right? Let me show you one of the ways that we can get around this. Well, maybe I'll show you two, because we have time to talk about it. I could follow this kind of a syntax. I could, hey, patients equals from P in, right? Select P. I still have my include there, right? And if I wanted to, I could put that back up on the first line. But notice as I hover, now it's a simple iQueryable of patient, right? And why do I want a simple iQueryable? We mentioned in our discussion earlier, then we can further and further modify very easily what query we're going to actually execute in the end before we actually call it to be passed the database and executed. So we might optionally decide to add a where clause or multiple where conditions as separate commands that we add one bit at a time. And eventually we're definitely going to do that, and then probably add an order by as well, and so on and so forth, right? So that's one way to get around, okay, the situation. By using the query expression syntax, it becomes a simple iQueryable of patient object. Now let me just undo for a second, because I do want to share a different approach altogether. Okay. Another thing we can do is AsNoTracking. There's a couple reasons why we would want to do that in our query, right? Okay, AsNoTracking, basically, every time we pull data from the database, Entity Framework Core implements what is called the change tracker. And that's how the system knows, have we modified any of the objects in the collection that we pulled from the database, and knows that we have to save changes going back, right? At this point, our data is strictly read-only. We're just showing our index view. And remember, this is a web application. So a request comes in, get routed to our controller. It prepares the data. Remember that little illustration? It takes the data, merges it in with the view, right? A little briefcase we showed and so on. We slice up the bits together. We put it into the view, and we return the view. When we're done, right? This all can basically go away to the garbage collector as far as that's concerned. So we don't keep it in memory necessarily at all, right? So all we need is a read-only version, okay? It's actually a little bit faster than pulling read-only data because we don't instantiate the change tracker. There's a lot of less work has to be done to get that all ready to go. So the AsNoTracking is a little bit of a performance improvement, right? Since we don't need to track any changes in this data as well, right? But also by adding AsNoTracking, notice once again we have an iQueryable of patient, right? So that's a couple things we can do there. Okay. All right. So that's good. We're going to leave the, well, we'll leave this alone for now. We'll be coming back and doing more work, but we've got a lot of other things to cover. So there's much more we'll eventually be doing in our index action later on if we want to, as I said, optionally add sorting and filtering and so on and so forth. But we'll leave that for another day. Let's come down here to details then. What changes might we want to make here? Okay, well, how the details works is we pass in the ID of the one record that we're going to focus on, that we want all the details for. So this is fine. We check if we actually have a value, return not found, you know, just in case they don't pass an ID number as we call for details, right? Assuming we do, then we come down here, we have our LINQ query, right, in place. So we go to patients, we include the doctor as well, and then first or default. That's a nice SQO, standard query operator, that is very efficient, okay? There's also single or default, but single will actually check for all the occurrences of the matching filter, okay? Whereas first, as soon as it finds one, it says, I'm done, right? So we might as well go with first or default here as far as I'm concerned. And then what we're doing with the lambda expression, we're passing basically the filter or where condition, you might say, if you prefer to use that terminology, okay, where the ID, the primary key, matches, okay, the ID that we have passed in, asking the details for this one patient identified by the ID primary key, okay. Now, if it's null, we return not found again, okay. Don't worry, later on we'll add more details of feedback being given to the end user, but this is good enough for now. and then now we have this one patient object, we return view for the patient. Okay, it might help if I bring up some of the views. We did talk about index. Okay, we've looked at this before. So basically we have a table, we have our header section where we have display names for all the columns. And then of course we actually have our for each loop where we go through all the items in the model, all the data, and showing the corresponding information. At the end, we have some links for edit, details, and delete. Okay, and notice that we don't have to specify, if we don't specify ASP-controller, it'll go to the same controller that we're working with right now, but the action is indicated, and we can optionally pass here a route, okay, and a parameter and name value pair. The name is ID, the value is what we're supplying. So in this, every case, it's the actual primary key, the items.id, right? Okay. And that's why, by the way, when we come here to details, we have the ID available to find and identify the one patient to show details for. All right, so let me bring up the details view, right? So we've looked at this quickly before, and we're going to be making a few changes as time goes on, but basically we have our description list here with our terms and our definitions or whatever phrase you like to use, definition, description, right? Anyway, the idea is we have basically name value pairs. We're displaying a label and then the actual values themselves, right? So that's what we're doing here. That's good. All right. So nothing really to change here except for maybe one thing. Why not add AsNoTracking, right? The reason for doing that as well makes it, now I know we're only pulling an individual one record here, right? So the performance difference, okay, is marginal or minimal, I should say at best, but still, okay, it's not a bad thing. We can add that, and that way the system knows right away we don't need any change tracker involved. All right. Okay, now let's get back to, we've done index and details. Let's get back to the actual CRUD operations. Okay, we'll start with the create process. I'm going to expand both of those. Just want to, before we go on, note some of the protections for us that are built right into the MVC system here in our controller. Notice that besides decorating the post here, oh, sorry, I'm so anxious to talk about that. I didn't talk about the crate. Well, there's nothing really much to say about the crate. We populate the drop-down list. Remember, that's the data that will be there for the selected doctor, and we return view, right? I'm going to open up the actual create view here for a second as well, right? So here it is. We have the form, ASP action is create, okay, the opening form tag. We have our validation summary at the top, and that goes along with the individual validation spans for each input itself, right? So the summary one is for overall comments about validation issues and things like that, okay? It's all inside of a form tag, the whole thing, and then we have our back to the index action at the bottom, and we have a little bit of a script section here. Basically, this is the validation scripts partial. This just gets all of the code in place to allow all these validators to work on the client side, right? You can feel free to have a look at that. It's over in the shared validation scripts partial. Well, it's not much to it right here. So it's just getting some jQuery stuff for validation, and away it goes. Okay, so back to the controller again. Not too much to say about the get, but then after filling out all the information here, once we get it satisfied and we can actually think about creating a record, then it will post back, right, to our create method. Now, what's this validate anti-forgery token? Okay, this is protection for cross-site request forgeries, right? You can look that up, find out all about it. I'm not going to try and preach everything there is to know about it, but it's a very, very good thing that the protection is right here by having a token that automatically is added to our form that helps prevent this type of attack, this cross-site request forgery attack. How does the token get there? Let me come back to the create page here. Notice our opening form, okay? That's it. The actual form tag helper here, actually, when it generates the HTML, will actually automatically add a token, right, to the view itself. It'll be buried, hidden deep inside the HTML of the page, but it gets posted back as we post the form here back to the controller. So it will be compared, okay, to the token value as it comes in. And there, if there is someone who is trying to do a forgery for our request, it will catch that and prevent that type of attack on our system, right? Okay, the other thing we see here are overposting attacks. That's where an attacker adds a name value pair to the data submitted, okay, along with the request, right? So we know we have a lot of data here, right? We have our OHIP numbers, all the name components, date of birth, all this stuff, you know. But, you know, we might have additional properties, secret or hidden properties in the actual model class, which aren't being exposed here. Perhaps, you know, only someone with more advanced privileges in the system, a higher security level, should be able to maybe edit a certain piece of information. So we just don't even show it here or allow the user to change it. But what if somebody out there, a clever, evil person, thinks, I bet that there's a property named security code or who knows what, right? And they could try, okay? They could get in. There's lots of tools like Fiddler that allow you to actually go in and modify a post in between when the page is sending it and it actually is sent off to the actual web server itself, right? So that would be an overposting attack to try and, you know, guess a name value pair and be able to submit information to our create process that it should have no access to whatsoever, right? So how are we protecting against that? Well, you see here this bind, okay? This is what we often refer to as the whitelist, okay? As we build our patient, we're going to say only these values, okay? Thinking about name value pairs. Only the ones with these names are we going to allow the system to use as it builds the patient, right? So if they had that secret property and they guessed the name of it, right, and they were going to supply their own value for it, well, if the patient actually had that property, if we didn't have this protection here, this whitelist saying only these things can be used as we build the patient, only these properties will be affected, then it would be possible for that overposting attack to succeed, right? So very good. All kinds of good standard practices being built in for us here as we go on, right? Okay. All right. Now, here we're going to actually try and write out changes to the database. Good rule of thumb, and we have talked about this before. Changes to the database should usually be wrapped in a try-catch, right? And that's a good practice for us. And we're going to implement that right here as well. So I'm going to come down here, try, tab for my basic snippet here. And essentially, virtually all of this is going to go inside the try part, right? So my whole test, my if statement here, okay, right down to here, I'm going to cut and paste inside the try. All right, so we come into the create, we've built our patient object, okay, using the whitelist to make sure we don't have any overposting attack happening, right? And then we can check the model state. As it builds it, of course, this will allow all the model to be verified again on the server side. That's important to note that maybe, that if, okay, sure, we have this all this great code and our validation scripts here are provided to the client, but what if somebody's using like Netscape 1.0 or some really old browser that doesn't even support jQuery, right? Well, the page will still be there, they'll still be able to fill it out, click the submit button, and the data will come in here and none of the validation was checked in the actual browser. That's okay. It is all double checked here again, okay? As the patient object is built, all the validation from our data annotations, our iValidatable object, which we just talked about, all of that happens, and we can check model state. It'll be true or false, right? Okay, so if it's false, what's going to happen? Well, we're going to jump out. We'll come over the catch block here as well, and this is exactly what we want to do, okay? We're going to prepare to redisplay the data because hopefully it will actually be able to show it on the client side in the browser. And then we return the patient object. The patient object is carrying with it all the feedback about all the validation errors as it goes, right? Okay, so that's good. So if it's not, there are no validation errors, if model state is valid, we come in here, we add the patient, right, to our context, and we simply call save changes on the context, okay, itself. And then what do? We return, we go back to the index action. So we're redirecting to a different action, okay? The name of the action is index, right? Okay, so that's good, right? The only thing is our catch block here. This is what was scaffolded. And, this is not, we don't want to just throw the exception. We want to actually handle it here. The specific type of exception we're going to be looking at here is a database exception. So that's going to come in like this. It's going to be a DB update exception, and we want to access its property. So I'm going to add a variable name here to actually give me access to the exception object itself, right? Typical kind of code we're going to write inside the catch block here would look like this, okay? Okay, we have our exception object, okay, our database exception. So I can get the base exception and check if the message contains this specific error message, because that will tell me exactly what the problem is, okay? Unique constraint failed, and then specifically it'll tell us that it's the patient's.ohip, okay? And then I know, yep, that's it. I anticipated that. That's exactly the problem. We have a duplicate OHIP number, right? So I can add to our model state a model error. Notice that here I can specify, first of all, the string, the key, where it's supposed to show up, the key. If I left this blank, okay, if it was null or an empty string, it would go where? It would go in that summary up at the top, right? That's where it would appear. But no, I'm actually providing a key here, OHIP. So when this message shows up, it'll be in the one right down, oh, actually, I guess it's up here. SP validation for OHIP. So it would be added or shown inside this span, with class text equals danger, so it's red and so on, right? So that's how that information gets back to the screen and where it wants to be. Now, what if it's not this specific error message? Well, of course, over time, if there are more and more reasons that we can anticipate for errors, we'll add more and more tests inside here and look for the message coming back from the exception for different things. But that's the only one. So else, well, if it wasn't the OHIP number, I have no idea, right? So I'm going to show a general message right up here in the summary by using an empty string for the key. Unable to save changes, try again if the problem's, go away for have coffee and come back and try again later, basically, right? Okay. All right. So that's it. I'm happy with this now on the create. I'm going to put a breakpoint in here because later on we're going to be doing some testing and we want to see what actually goes on. But let's go on and talk about edit next. Okay. Now the edit get, right? Well, it isn't too bad either, okay? I'm going to leave it. And by the way, find async, again, it's so efficient. I'm not going to worry about changing it with the AsNoTracking. I don't normally do that with edit anyway because the object itself, I want the change tracker to be made aware of it as soon as possible, right? So there's really nothing in here that we haven't changed already that I need to change at this point in time. We still have our popular drop-down list. Now in this case, of course, we actually are passing the patient object, so it will pre-select the current, right? Because we're editing an existing patient. It will pre-select in our select control for the doctor the current assigned doctor, who's the primary care physician of the patient. All good. Again, most of our work is going to come here in the post. Once more, we have our validate the anti-forgery token, right? Notice it's set up with a whitelist here as we build the patient object, right? That's all good. And of course, it's decorated with HTTP post, so if an edit request comes in that's a post, it gets directed here. That sounds fine, and this is all good so far, but this is the one that we're going to do the most work in. The most work we have to do is actually, we're going to change the approach, right, altogether. Because what it's doing here is it's building the patient object and then basically creating a new patient based on the data coming back from the form. But remember we were talking a few minutes ago, what if there are some additional or secret properties in the patient class which we aren't even exposing or involving in this operation with the user interface, right? what would happen to them if there was some secret property in the patient, right? If I just build a brand new patient based just on these values, I am going to basically have null or nothing to provide for that secret property, right? That is probably a situation I need to avoid. We need to plan for that. So that's very important going forward, right? Okay, so what are we going to do here? Well, we're going to take a different approach altogether. We aren't going to use this whitelist. We aren't going to actually even create the patient object right away. But don't worry. All the data still is passed in, right, from the client, the view, I should say, from the view itself. All the data still comes in, okay? All right, so what are we going to do? Well, obviously we can't do this, so instead we're going to go and get the patient to update. So we're going to go to the database and get the patient first, identified by the ID itself, okay? Patient to update, okay? So we can go to context patients, first or default, and away we go. All right. Now we should check, you know, just like there was a if there to see if we actually had an ID. I should check that I actually have the patient, right? That I went to get it and, ooh, it still is there, right? It hasn't been deleted by somebody else in the meantime, things like that. Check that if we got it. Otherwise, we're going to return a not found, okay? All right. Then we come down here and we have our test for validity. Wow. What we're going to do is we're going to try updating, okay? Instead, we're going to try updating the patient that we went and got from the database, our patient to update, with the values that are posted. So instead of saying if model is valid, I'm going to replace that with this bit of code. Okay. We just have a wait because we do this asynchronously, okay? We're going to do this command, TryUpdateModel, okay, asynchronously, right? The model is based on the patient class. And with TryUpdateModel, you can see here from the IntelliSense popping up, we pass the actual model object itself, okay? It's a patient, as we know, because we have that defined. And then we have a prefix, and then we have parameters, right? And the parameters are LINQ expressions, in other words, lambda expressions, right? So that's what we see here. The patient update, the one we got from the database, is right here, okay? This is just blank. We aren't using that parameter, but we have to have the empty string here. Then we have a whole series of LINQ or lambda expressions, I should say, okay? This is essentially our whitelist in this case, right? From the data coming from the client, and it's all available here, even though I didn't grab it up here, it's all available in the posted data, right? So what I'm going to do is I'm going to try update my patient update object with the OHIP number that was posted, the first name, middle name, last name, the date of birth, etc., right? So this is all the same properties of the patient update that I had previously in the whitelist in the top up here, right? Okay. So this accomplishes the same protection for overposting attacks as we had before, plus if there are some additional properties we are not exposing to the client at this point in the UI, then they're protected as well. They are not going to be affected in any way by this change. That's very important going forward because we will eventually be adding some, I can guarantee it right now. Now, we don't call update because we've already updated, right? So I just get rid of this. Okay, we don't need that line, okay? All we really do is we call our save changes. But we have to rearrange things a little bit here. For some reason, it puts the return, the redirect back to the index action way down here. No. Very simple thing to overlook, but don't overlook it. Very important, always when you're making this change to the approach, put it inside the try. So if we successfully save changes, then we go back to the index action. Bada bing, bada boom. Now, here's a new catch. This is the only one that had a try catch in place, was the edit, right? This is for our DB update concurrency exception, okay? You know what? We're going to leave this one alone for now, except I'm going to get a red underline here because we no longer have an object named patient. What we have is we changed the name to help us remember that we are doing a different approach here, that we're doing the TryUpdateModel approach. We changed the name of the object to patient to update. Ah! Rats, okay? Control C, Control V. There we go. Okay. So don't worry, we will later on be coming back when we get to the point where we're adding timestamp, row version, whatever you want to call it, for concurrency control. We will be doing work inside this catch block. But you know from experience by now that we can have multiple catch blocks, right? We catch, first of all, if there is a DB update concurrency exception, then we can check for our DB update exception. And this is exactly the same code I had in the catch block for our create process as well, right? Okay, so good. All right, there we are. Okay, so that's all happens only if, right, it was valid to begin with. Now, the only change I have to make here is, of course, once more, patient to update, patient to update. So we re-prepare the drop-down list, right? And then we return to the view so all the validation errors can be shown, including any we've added here in our own code as we add these model errors to the model state, right? That's it. That gets us through our delete, okay, or through our edit process. Now, I know it's a long recording, but we're almost done here. So let's come down to the delete. Okay, so the post for delete, right? Do I have to do much here? Well, I've already added no, I haven't. Okay, sorry, the get for delete. I am going to add my AsNoTracking here, right? I'm including the doctor. I'm not using that find, okay? So I'm going to add AsNoTracking, even though we're just getting the one record, okay? That's the only change I'm really going to do inside the get here for delete, right? Coming down to the post, okay? What I'm going to do, yeah, it's set up with this find async, but you know what? I am going to take this approach because I want to include the doctor, because I'm going to redisplay the delete directly from here. Now, this is a change from how it's shown in the 10-part tutorial, right? This is a variation on the approach. I will accept the tutorial's approach, but I encourage you to think about doing it this way, because later on it's going to tie in with some of the other changes we want to make more easily than if you follow the tutorial approach. So you can make it work either way, but in the long run, this is going to be easier, right? I'm just going to replace the LINQ query with the exact same one we have up here, except obviously we don't want the AsNoTracking because we're going to be making changes and saving it back to the database. So AsNoTracking would prevent us because we won't have a change tracker in place. So once they've confirmed, yes, we want to delete this particular record, we get the ID of the record coming in here, right? We go and we get the patient from the database, including the doctor, okay? And we're ready to go. So again, we need a try catch. Try, tab, right? Now the truth is, in this case, all the code we had goes inside the try block. Everything here, Control X to cut it all. I'm going to put it all inside the try, right? So if the patient isn't null, okay, we were able to get the patient, we call .remove the patient, right? And then when we save changes, it will actually generate the SQL to delete the record. And then as long as that's successful, we'll redirect back to the index action. Good. Now, our catch block, okay, will be a catch for our DB update exception. That's the only one we're going to be concerned about, right? So there's no real reason our delete should fail, right? As long as we can talk to the database, we should be able to delete the record. So really, I'll just say my general message to appear in the summary at the top: unable to delete record. Try again if the problem persists. See your system administrator, right? Okay, but something missing altogether then that we're going to want to add in here is the return view, right? So we're going to, at this stage, if there was a problem we couldn't delete the record, we're going to return the view. We've added this model error, so it'll have a chance to show the user, yes, there was a problem, we couldn't delete the record, and away we go. All right? The difference between this and the tutorial has you actually go back to the get for the delete, and then redisplay it that way, and then you have to pass the information about errors and so on and so forth. This is an easier approach in the end, especially when we add some further changes down the road that we're going to do. So we directly return the view right from delete confirmed, and this way we make sure it's there. But, very important, what if we need to show this error message? Because right now, because of how it assumes things are going to be set up, the patient delete is missing something. If you come in here to the patient delete view, there is no validation summary, nowhere to show those error messages, right? So this span up top here, this validation summary span, I can just borrow it either from the create, the edit, okay, wherever it is. Coming over here to delete, I can just put it right there, okay? And by the way, we really don't need this H4 as well, because it already is pretty clear what we're doing. I'm just going to take that out now. Okay, so very important. Don't forget, okay, I always get a couple students losing marks when they hand in their work because they forgot. They did follow my suggestion to structure the delete process this way, but they forgot to add the summary control into the delete view, so it doesn't have a chance to show the error message, right? Okay, all right, good stuff. So I'm going to come back to the controller again. Let's come into the edit post. I'm going to set a breakpoint here. Gives me a chance as we do some testing here to show you a few of the possible errors and how we're handling them, right? Good review of the 3 stages we have in the overall validation process as well. Okay, so here I am up and running, right? If I come to patients, okay, so let me click create, right? Now, right now, if I click the create button, look at all this feedback I'm getting, right? This is all coming from my data annotations. Excellent, right? But notice we didn't hit our breakpoint. It didn't stop execution in the controller because we haven't actually posted back. Everything is happening here, client side only. Now I'm going to switch to using edit because that way it saves you watching me try to type and fill in all the information. Let me come into edit. And once again, let me just take something out that's required here, right? Last name, click save. There we go. You cannot leave the last name blank. Same thing. We have not hit our breakpoint because it didn't actually post back to the controller yet, right? Because of that issue, right? Okay. Let me point out something else here. Our coverage is OHIP, okay? If I take out the OHIP number and click save, there's no validation error message about the OHIP number being missing, even though they're OHIP coverage. Why not? Well, it's because that happens only in the iValidatable object. Remember, we added that logic in there to make sure that if it's OHIP coverage, that you must have the OHIP number. And if it's not OHIP coverage, you're not allowed an OHIP number, right? Another one we added there is the date of birth, right? So if I put a date of birth in the future and click save, still no feedback about the fact that this is an invalid birth date now. I can't have a birth date in the future. Well, but if I leave the name, if I if I put the name back in here, Flintstone, okay? Now, all the validators that are available to check locally here should be successful. And I click save, and yes, sure enough, I'm in the controller. I've hit my breakpoint, right? So I have the ID. I'm going to go in. I'm going to get my patient. Okay, I'll step over that. So we now have our patient update. Look at all the information. This is all the information about Fred Flintstone that just came from the database. Okay, so I can step over this. Here I'm in my TryUpdateModel. Okay, so I'm going to try update all of these particular properties. So I'll step over that and look at that. We jump down to here. Why? Because it is not valid. Okay, our model state is showing that it is not valid. So we skipped over everything. Now we're going to prepare. I'll just skip over that. I don't want to prepare it. And we'll go back to the view. Bada bing, and here we are. Now we're getting those additional error messages showing up, the ones that came from iValidatable object, right? Okay, date of birth cannot be in the future. You cannot be blank since the patient has OHIP coverage, right? Okay, good. All right. I'll just get X out of this. Now, so we've seen client-side validation, validation that happens on the server side, but through iValidatable object. We still have never sent data to the database yet, right, to actually be updated, okay? So I'm going to do that now. Now, something, as long as I pick a couple people that have OHIP numbers, I'm going to go back into Fred's for a second. I'm going to steal his OHIP number, Control copy, go back to the list. I'm going to go into Wilma and give Wilma Fred's OHIP number, right? This should now be a database error, right? Because only the database has a chance to check for a duplicate OHIP number. So I'll click Save. We've hit our breakpoint here in Edit Post, right? Coming along, okay? We'll try update model. It worked. Everything is valid as far as the validation rules we have in place, both from iValidatable object and all the individual validators on each property of the model class itself. So I'm going to come in here. I'll try to save changes. And here we are. Error occurred while saving changes. Unique constraint failed. Patient OHIP. Good. All right. Carry on. That's what the message is. So we'll add to our model state. We'll show it. The key is OHIP. We'll show this message. We're adding that to the model state. We go back. We prepare our drop-down list. So at least it will, when the data appears on the screen in the view, it will have the right doctor selected for us. And away we go. I can just click continue. And here's our view. Unable to save changes. Remember, you cannot have duplicate OHIP numbers. Yes. So we finally seen all three spots where validation occurs. And that's it. Good stuff. All right. Well, I'm going to stop and start the recording one more time here.